Hi everyone. This series of videos is going to take you through pages 15 and 16 in the packet, which is going to cover compound interest. Compound interest is actually one of the more relevant things that we study in algebra because it does have quite a few implications on real everyday life, especially outside of the math classroom. So while sometimes it can be hard to think of some of the things we do as applicable in our daily lives, I mean, nobody really thinks about going to the grocery store and solving a system of equations to figure out the best combination of apples and bananas to buy. Compound interest is actually around us all of the time. So whether we pay attention to it or not certainly is up for debate, but compound interest is all over the place 24/7. Your parents probably deal with compound interest when it comes to their banking, when it comes to things like house payments, credit card payments, car payments. When you start thinking about college and you start thinking about saving money for college in a bank account or using scholarships and loans to help pay for college, those are all related to compound interest as well. So what's interesting is once you understand how it works, you'll really be able to start to look at a lot of the things that you'll do, especially as you become more of an adult and more financially responsible, through the lens of a mathematician that understands the numbers, not just a person who's being sold things. One of the things that I think you'll find empowering about understanding compound interest is that you'll be able to listen to being sold something, an advertisement, for example, for an interest rate on a car where somebody's trying to sell you this idea that you should be purchasing from them. And you'll be able to really discern whether a good deal is a good deal or not, because you'll understand where those numbers come from, why they work the way they do, and the long-term implications of those numbers. So hang in there for the next few lessons, because I think you'll find that in the long run, understanding this stuff will give you a really good leg up in understanding how the very complicated financial world works and give you a little bit of confidence that you might use. In question number 1, it's just going to lay out a very basic investment scenario. This is actually probably too basic even for practical uses. Usually they don't even give us these very simple options. But the purpose of question number 1 is just kind of set the foundation so that you can understand what it means to invest. And so we can start to compare different types of investments so you can see why investing certain ways is as popular as it is. In question number 1, they're giving you the same exact situation twice. You're going to start with an initial investment of $1,000, but each account is going to earn interest a different way. To make sure that we understand what interest means, interest is essentially free money. Money that the bank gives you as a thank you for leaving your money in the bank with them. So interest is a great thing. Interest is, as I said, free money. You don't have to do anything to earn interest other than have the patience to let your money sit there unspent. So a little bit of extra money that you have sitting around, even if it's not as much as $100,000 or $1,000 like in this problem, can earn interest. In this problem, we're going to see what happens to a nice round number like 1,000. So it says in letter A, after 1 year, which option is better and why? So let's think about this. And I'm actually going to do the table for letter B and question letter A kind of simultaneously, because I know that initially in both options, we're going to start with $1,000. So I might as well fill that in now. In option number 1, it says we're going to earn $80 simple interest each year, which is where the bank says, hey, thanks for giving us your money. I'll hold on to your $1,000. I'll add an extra $80 in there every year as a quick thank you. So that means after 1 year in the bank, they'll have added in $80 extra to your account. So your account will now be worth $1,080. The next year, they'll add another $80. The next year, they'll add another $80. So they're basically just adding that money automatically to your account. And when you think about it, that must be an arithmetic situation. So I'm going to just take the time right now, because I'm already here, to write the equation for this. This is going to be arithmetic, but I'm going to write it with a slightly different notation. I'm just going to use the traditional x and y notation, not the n and t of n notation, and I'll explain why momentarily. But for now, let's just kind of make that transition here. The initial value we know is 1,000. It's arithmetic and I'm adding, so I know this will have a plus sign. I'm adding $80, so 80 and instead of n, I'm going to use x. Again, I'll explain my choice in a second, but bear with me at least for now. We know that option number 2 has a similar pattern, but it's not earning $80, it's earning 8%. And this hopefully reminds you of the videos that you did yesterday, which were the percent multiplier lesson, because 8% is a multiplier, it's a geometric situation, and we need to convert that 8% into a proper multiplier that we can use to help us understand. In fact, I think I'm going to skip and do the equation for this one first, so that I can use the equation to generate the table instead of the other way around. So thinking back to what we did in the previous lesson, we know that we need the initial value, which is still 1,000, times, because percentages always yield a multiplier, which means it's always geometric, times 8% interest. That means I have 100% of my money in the account plus 8% more that the bank will kick in, which gives me 108% of the money as it grows. 108%, if I move the decimal 2 places to the left, yields a multiplier of 1.08. Again, to the power of your variable. I'm going to use x instead of n. I'll explain why momentarily, but bear with me on that choice. Now, the reason I chose to do the equation first is because I just want to make quick work of this. And I think because we're dealing with percentages and the table's not as easy, it makes a lot of sense to just have an equation I can just quickly plug into. For example, 1,000 times 1.08 to the power of 1. That'll give me 1080. If I copy and paste that and just change the power to 2, I'll get the second year. And we can repeat this process for as many years as we want to, although this table only goes to the 4th year, so it's not like we have to extend it too far. And we can start to get a sense of the growth here, especially as you compare this to what's going on in the other table. Letter A, it said after 1 year, which option is better? I can only assume better means more money in your account. So if I compare now, 1 year, looks like that's actually the same. After 1 year, it doesn't seem to matter which account we have, because it appears that they both yield the exact same amount. After both years, we'll have $1,080 in the account. But check out letter C. After 4 years, is there a better option? Now it seems as though there is, because if in the first option I'm at $1,320, I've still done well for myself. I've still made money, but I made more money in option 2. So it seems as though if you compare them, option 2 is better because you'll have more money in your account than you did in option 1. Try, if you can, to use your equations for letter D. I say use the equations because the table stops at 4, and I sort of doubt that you're going to continue each table all the way till you get to 20 years, because that seems like it's going to take a long time. So consider using your equations. If x represents the number of years that the money has been sitting in the account, then you should, in theory, be able to simply plug in the number 20 for the letter x, do that math, probably in a calculator, and then you'll be able to compare the two. I think you'll be surprised. Without saying anything about the results, I'm going to ask you to compare them for yourself and see for yourself. Does it make a difference in option 1 to have a simple interest where they just add a flat rate versus option 2 where they add a percentage? Does it appear to make a difference? And if so, how significant is that difference? Which option is better and by how much? Ponder that, and then in the next video, we'll hopefully make some sense of why that difference is important.